our project. So programming, this,
I
and
can see it live yet.
we are already live. And Spatula. And okay, so let's do it though. So last time we discovered that pattern matching is one of the hardest features so far because of all the cases that we want to treat, right? So we have the case in which you have nested stuff. We have the case when you have the disjunctive pattern matching, or the OR pattern. We have the case in which you have bindings or literals. So all of that, which is very, very overwhelming. And we ended that session saying that creating a few functions. So they are all here. So you have check exhaustiveness, create bind, skip pattern, and guard, and so on and so forth. Check all branches was also created during that, I guess. Um, so now, what should we do now? We
Yeah.
have a function only for the type T unit.
Yeah. To start, we have to review stuff, man. Uh, yeah. So let's go to the types first. Let's see what types we have made.
The types first. Oh, the types you mean this. Okay, so let's remove that. Let's go down here. So we made this guy, pattern. And
Yeah.
the pattern, all the possible patterns that we can have in the pattern matching stuff. And then we have the sum type with the label and the list of patterns. We also have the variable with the name in which, well, you are just like a catch-all case. You have a literal there, and you also have the disjunctive and a wildcard. Hello, Mageta.
Anonymous. Let's
Yes.
comment the disjunctive pattern for now, man. Because yeah, there is a lot of complex there. Like there is
Okay.
even some other stuff that we were not thinking about. For example, they even need to have the same bindings in.
Yeah.
So yeah, it can, well, I guess. But yeah, it can be very hard. But okay, we have the variable one, sure, to generate the binding. The wildcard, that is basically the same but not generating a binding. The literal and then sum type. The sum type takes a label and the list of patterns.
Yeah.
Okay. Yeah, I still don't.
Are you okay today, Mageta?
Mm-hmm.
Okay.
Just sleepy, but that's a
Yeah,
standard.
if you have to go because you're tired, that's okay. Yeah, that's understandable.
Otherwise, I would go all the time.
Okay, so questions, Nathan.
Um, oh, I think we are fine.
I think
So, okay, what do we have on functions? Like top down.
okay, so going back to this, so we were discussing how to do type check expression when you have the e pattern matching, the new one, not the one
Oh,
that we made before. Yes?
okay. Mm-hmm. Okay.
And then we have the expression that you're gonna match, like the match like match something off. This is the that, and these are the list of branches, right? The list of patterns, sorry, patterns with their respective branches, I shall say. Then we pick the expression that you want to the pattern match. We type check that and we reduce it, so we discover its type. Then we check for exhaustiveness, and then we call the function check exhaustiveness, and then we do check all branches. So
Okay.
yeah,
So the check of branches is the one that is intended to.
yeah,
Oh, let's go.
that's the one that I you said that we should change the name because it's not only checking, it's also returning the type, right? If you go here, so we have the type of the expression that we want to pattern match, the environment, and the list with the pattern, the potential guard that we also added, and the respective range. Then we pick each one of these triplets, and we type check the branch, right? So this expression here. Then we grab that list of types, right? And then we check if they are all the same, and if they are, we return it, and that's it. That's it. Okay.
Yeah.
So this is the function. This is the function that it was kind of straightforward to make. The other function is the for check exhaustiveness. We made this, and only for the unit type.
Okay.
And this function is you is you
I'm
is
admiring this code, man.
this function is being used only in a fold, right? So we check the conditions like, oh, if you have a literal unit and you don't have a guard, we are okay. You can end up like you don't, it's not a problem. And we do all the special cases for the unit, which in this case are only 6. Having or not having guards, if you have a variable or a wildcard or whatever, something else with unsatisfied is going to be throwing an error. And if you are already satisfied and you have something else, you're going to print a warning saying that this case is unreachable.
Let's make a comment on what the function is supposed to achieve, right? Because like,
This one?
yes, I guess it's like different stuff, right? No, not this internal function. I mean,
Oh,
the
the check exhaustiveness?
yeah,
Okay.
because like first of all, we have to check if the patterns are valid, right? Like with the data type that we were given, like to match, right?
Yeah. So for every type, we iterate through.
Oh, there is only one type, right?
Oh, right now, yes, but we're gonna make for each one of them.
No, I mean from the perspective of okay, the function it takes a type and patterns and stuff like. What do you mean by for every type?
Yeah, for every type. Right now, you only have for units, but you're gonna make for other ones. That makes sense. Like you can't have the abstraction, I guess.
Okay, go on.
We iterate through the list of patterns.
Oh, dude.
Check if they are uh, possible to use.
I think I got it. You say for every type in the sense of it receives something of the type.
Yeah.
So it can be any. Dude, but that's what any function does.
No. For the type.
Okay.
To use for the received type. If some pattern is unreachable, well, yeah, some pattern is unreachable, or if it should not happen at all, aka error out.
Wait, what is the should not happen at all?
This.
You mean or as the ah I'm not sure. What is that thing again?
Take into
The
account
unsatisfied
if we
and
have
other.
guard or not.
Oh, but is when you have a that is when you have a wrong pattern, dude. That's the same situation as the first.
If you have the wrong pattern.
Yeah. Like take a look on the line 9, like down, right? The other there is because you're not matching a unit or any other
Yeah,
value
that
pattern.
pattern for that's received type shouldn't happen at all. Yeah.
So the if should not happen at all is the first line, right? They are not possible to use.
Wait, I'm confused what you're talking about.
Yeah, so see the first line of your comment.
Yeah?
That's to say if you are matching something of the type unit, you cannot pass an integer
Oh,
pattern,
I
right?
see, reachable. Yeah, so it should end it here, I guess.
Okay, that's also okay. And then there is the one of lighting stuff, right?
One of what?
Of lighting stuff, like it's not exhausted, right? Not exhausted.
I don't. What is not
Uh,
exhaustive?
like the check-ins that we are doing, we are checking for like if the thing is unreachable and also if it is exhausted, right?
Yeah, we are checking. Um, okay, we are checking reachability, ability, and exhaustiveness. Exhaustiveness, I guess.
By the way, uh, uh, yeah, the guard stuff doesn't interfere with the unreachable stuff, right? Uh,
No, it interferes because if you have only one pattern, but you have a guard there, we're gonna.
no, that's the exhaustive part. Like you're
Oh yeah,
still
yeah, yeah.
like
Sorry. Yeah, so I'm not sure. I'm not sure if the reachability is being
because
matter.
like if you have one that is like a catch-all cases, you don't care if the next one has a guard or not. Like anyway, it's unreachable, right?
Yeah.
Okay, so one last thing to think about. Okay. So okay, the function is supposed to take a type, see if every pattern is valid, and then see the complicated part, that if there is something unreachable or non-exhaustive. Uh, so yeah, so we are starting by matching the type, right?
Yeah.
This tells everything for us. And then let's see, the whole thing is a fold uh, on that list of branches and stuff. And then we are returning this satisfied or satisfied, right?
Mhm.
And we really don't need any result of that function, right? We just want him to give an error,
Yeah.
if possible. Okay. Do we really need to?
To what?
Well, doesn't matter for now. Like to do that unsatisfied, satisfied, or could we just do it inside, right? We don't, right? Because we want the unsatisfied to be the first state and stuff, I guess.
Yeah. We no, but we are only using it internally. The unsatisfied is only being the satisfaction data type is only being used here. It's not being used by any by like other places or stuff.
So let's see. We start with unsatisfied. What was that to me anyway? Like,
We are not satisfied in terms of being like uh it is unsatisfied in the sense of you need to show to us that there is a branch that will happen for sure. Like there is a way of getting out of the patterns.
oh, like you need more patterns, right?
Yeah.
Okay. Okay, we begin as we need more patterns, and then
Yeah.
we go to the list, and then let's see if it's satisfied. Then it makes sense. It's an unreachable case, right?
Yeah.
Okay. So let's see if it is unsatisfied and it's a unit. And wait, isn't?
I got it.
Oh, that's the current element, right?
Yeah. The one on the left is the accumulator and the one on the right is the current element.
I forgot about that. So it's the pattern, maybe expression, and the last one that we never care.
Yeah.
So okay, if it's unit and it doesn't have a guard, then it's satisfied. It's the only thing you need. If it has one, then it isn't satisfied.
Yeah.
Okay. If it is a variable, it will be satisfied if you don't have a
A guard.
guard. Okay, the
The same,
wildcard is just the same thing.
yes, the same applies for the wildcard.
Okay. And what happens if we have something else, right?
Yeah, because in this particular case of the unit, the only patterns that we care are those three, and the variations with guards or not. Everything else is in error.
We only have those three patterns, right? Variable, wildcard, literal, and sum, right?
Yeah, we have the sum, and we had the disjunctive, but we commented that out.
Yeah, too complicated for now. So, like, without using the disjunctive, that's totally done, right?
Yeah,
Because the sum type would be a error there.
yeah.
Nice, nice, nice. So yeah, let's go to the other types.
Okay. So something that I was thinking, I think I already discussed this before with the data type.
Aren't we gonna try to pattern match a unit first to see if it works? Before doing the others?
That's not a bad, a
You
bad.
mean you mean tests?
Yeah.
Oh.
Yeah, he means that. He means that. Yeah. Um. Okay. So. Yeah, but the thing about having about testing that, do we have a value unit? Like, have
Yes.
I don't remember parsing that.
It is just open close parentheses as far as I recall.
Can we have let's check here.
Oh,
Unit.
if we don't, we can just
Oh no,
check
we
on
do.
the.
You're right.
Mm,
Okay, cool.
could
So
be
let's
new as well.
let's do
To
what
this.
no, but we can change that. That's not a problem. New this?
Yeah, that's better.
Yeah, but then you don't need to be on the parser, right?
Yeah, you don't.
Can just be in the context.
Um so let's do what Magetta suggested because I think that's pretty cool. Okay, so I'm actually gonna create a folder
Yeah.
for this guy
Let's see if
because
we have the worm. Oh, it should
so
work out on a site, right?
Control D, no, I forgot. I can make the folder later. Okay, so we're gonna try to pattern match a value, right? So let's copy this. What should this function do? It should, I don't know, like match what? It should match unit, right? So we're gonna receive a value. We're gonna see that this value has the type unit, right? Then we're gonna pattern match it. So value. We made okay. So we should check all the cases now. So let's do what is the first one? What is the first one that you guys want to test?
Um,
Let's
wait.
put just a
Wow.
name.
Let's try, dude. Just try the simplest thing, the wild card.
Yeah, that's not bad. Okay, so
Just see if the
string.
mechanism works.
Yeah.
That's it.
I don't know.
Wait, but you haven't defined steel lamps.
That's not a problem.
It's not a problem.
Yeah, because we're only gonna test the unit case and everything. We're not gonna reach that undefined stuff there.
Do we have the parser for the underscore only?
Do you have what?
Like underscore, like the wild card.
Oh, dude, I didn't make the parser for patterns, so I think we're gonna have to do the way that Nathan likes.
Oh, loading the
Yeah, what
product.
Yeah, loading it by scratch.
The only way to go, I guess.
Yeah.
Okay.
Okay, so we need to make it compile first because we didn't update stuff. So the first thing that I want to do is to comment things out. So let's comment a few things out. And my Emacs decided to froze. Okay, that's.
I think it
And
was the LSP.
I certainly hope so. So where do we have pattern? Oops,
Hmm.
here. Okay, so this
Ah,
guy we're gonna comment that out
okay.
because this will not compile with this. So let's remove that. Okay, the next one is the evaluator. Again, Emacs, thanks. What is the function that is complaining? This guy. Okay, so we're gonna just comment this, and we're just gonna say eval expression env e pattern matching. Okay. Okay. Okay.
Nice.
It does things. Okay. So now let's go to main and let's create our test sample here. So test sample. So this we want this to be an e pattern match, right?
Mhm.
Um,
Yeah, go to the AST. I think it's easier.
Wait, I have to get used to these new shortcuts of moving stuff.
Huh.
Um, okay, so this. Okay, so e pattern match. Then we have an expression, right? So we're gonna have to make an expression here, and then we have a list, right? A list of triplets. The first one in the triplet is the pattern. So we want the p wildcard in here.
Mm-hmm.
We want no guards, and we also want an expression. So let's put a need literal because we don't actually care about that. So let's put, I don't know, e integer, l integer
How
1.
would this wildcard work? Because think about that, for example, a tuple. You can pattern match the first two elements like a triplet actually.
No, no,
You
no, but
could,
no, but that's because that's what you're talking about is the nesting, right? So what
yeah,
if you, yeah, so we're gonna tackle that. Uh, and that's why, for instance, we have recursive stuff. So in the case of the tuple, the
it just recurs for every element and see if it all
yeah,
matches.
yeah, I don't know how
Mm-hmm.
we're gonna do that with this data type, but it is what you said. Then we have the value, right? So we want to, this needs to be an
A
expression. So this will
literal,
be an literal of L
a
unit.
unit, and this that.
And I think that's it.
I hope so.
Uh, okay, so I don't have this in scope. Which things do I have in scope? Do I have all the, oh, I don't have the types. Okay. Okay, nice. Okay, what else do we need? Is that it?
I think so.
Okay, so we're gonna do control this, typer, and we're gonna call type check expression, right?
Yeah,
I have a question. We were making, we aren't you using create binds? Create binds.
just a sec.
Yeah, we need to make this function to test it. Nathan, we forgot about that.
I just returned the env, but I said to you that you had undefined.
No, no, wait. Oh, you're not talking about this undefined.
Oh, okay, we have, yeah,
You're talking about the other one.
yeah.
So what is the create bind supposed to do again?
Wow, I don't know what you meant by create, but you have the patterns and they generate the binds, right? So that's it. But in that case, you are, oh shit.
Why do we need the
Actually,
type? I forgot. Why do we need a type?
Wait, let me see.
This type is the type of the value that we are trying to match.
Oh, okay. It's because like the binds that we're generating are for types, right? So if you have something like the sum type, how do you know how to bind the like internal patterns to the thing? So you have to access the nested types, right?
I'm
So the
still
sum
confused.
type,
Wait,
okay, some types have types inside, right?
yeah.
So yeah, if you like are typing the pattern of a sum type and you were to bind like the third thing, how do you know the type of it?
Wait, I'm still confused. Why do we need this guy?
Yeah, I will write an example.
I remember that this is creating the... Oh, it is because you need to know the types of the sum type. Yeah. I remember now that look like I remember that the code of the I wrote of the back in the day version. Yeah, we want this.
Yeah.
Okay, so the question now becomes, which ones do we care for the creation of binds? In my mind, we only care about the T algebraic. Is that correct?
I'll be careful. All of them.
No. What
You
we're gonna
mean the ones that you generate?
Yeah, what we're gonna care about what we're gonna do about the other ones, for instance.
Man, like, what are the only pattern that generates a bind? Well,
The T
yeah.
algebraic.
No, it's the variable, right?
It is the variable. Wait, I'm confused. You mean T variable?
No, we have a pattern variable, right?
No, that I understand. That I
So
understand.
yeah, it's the only pattern that generates bind, right, by itself.
Yeah, but I'm not talking about that. I'm talking about the type that we are receiving, right?
Oh, okay, yeah.
What should you do with every other type aside from T algebraic? Do we care?
Wait, dude.
I don't think we care.
Oh, that's the thing we talked about, Lemos. I don't know if you remember, dude. Uh, doesn't matter what is the type, because the type will not say if you generate binds or not. The pattern will say that. Actually, you have to match the pattern.
No, we will do that also. I'm I
No, but doesn't make sense you match the types there. They will not say you anything, any information.
well, I don't know if I agree with that, but let's go with that then. So create binds, you're gonna receive a type and you're gonna pattern match here, right? So the only patterns that I think we do binds are the p sum type.
Yeah, it's literally variable in anything that is like nested patterns, right? Because they could be a variable inside.
Yeah, and then the p variable. Everything else is everything else we do what with that?
Just, just give it back, right?
The environment.
And do that with some type for now, right?
Do that with some type. Uh, Wait, why are you gonna do that with some type as well?
Like just for now, not as implementation.
Like this.
No, yeah, but the variable one you have to actually implement, right? Otherwise you can't test now.
No, we're gonna use the wildcard one. We don't need to implement the variable.
Oh, okay.
Okay. Okay, so now we just call type check. Yeah. Okay. So type check. Oh, dude. Okay, we also need another stuff in the in here. We need to make. I don't know if we already have that. I don't. Oh, we do. Type your initial env. We do have. Okay. So what is the type check expression? Okay, so type check expression initial. What is the name? Typer initial. Typer initial env. The expression is this test sample. Uh, okay, so how do I get rid of that? Run except t. Do I have that here? Run except t. I do. Okay, so let's just go this and put run except t on this. Okay, so the answer is a right integer.
Is that
Is that
right?
right?
I don't know. Make a guess.
uh, yeah, that seems to be
Yeah,
right.
it is. Okay.
Okay, so what other test do we want to try?
Algebraic type.
But wait,
Wait,
unit.
algebraic
Algebraic
time?
pattern.
No, unit is the only thing we can test, Magid.
Oh,
Yeah.
right. Yes. Okay.
No, but we
No,
But
can
but
test.
you can
No, but
implement the variable and
no.
then do an identity.
But we can change the triplets. We can change the triplets.
mhm.
What do you mean?
It's
Yeah,
just like
right now we are using
otherwise
wildcard.
I'll pass out here.
So what if we add another branch here with, I don't know, a p variable, and then we add, I don't know, what name x to it. No guards, and an e literal L unit. I don't know, right? So yeah, this should error out because the branches have different types, right? Nathan,
Uh,
do you agree?
Also, but you will fail first, right?
Yeah,
Because the
it should
X
fit.
will be unreachable.
Yeah, that I don't. Oh no, it will do the print a warning saying, oh, this branch is unreachable, and then it will error out saying that the branches have different types.
Okay.
That's my expectation. Okay. Look.
Yeah, and dude, implement the variable already. Like it's literally just inserted to the map.
Okay, so implement the variable already. Okay, so it's basically um, this basically grabbing. So which one of them? I think it's the normal one, right? It's not the kind one and the alias one, right? It is the normal
Yeah.
one. Variable, uh, variable types. This is gonna be equal to map dot insert, and then we're gonna put. Wait, what is the type of the thing? Oh, it is type prime. That's what you said. Okay. The type's gonna be that, and we're gonna pass the original env, right? So I always forget. Is that the correct? Oh, it's typer env here. Okay. So this is not env. This is variable types. Okay, done. So what should this do then? How can we test it? Nata.
Just bind the variable and return it, I guess.
That variable will have the type unit, right?
Yeah.
Yeah, so we need to change this guy. Oops. This guy needs to be L unit. And this guy needs to be an E variable of x, right?
Yep.
Okay. Yeah, it worked. Okay, so let's implement the one with the sum type now. Is that okay?
I guess it's not.
I guess it's not. Why that's not okay?
Because we have the other things that are easier to implement.
But everything is hard. We're gonna be running circles at some point.
Yeah, but you see the function that you were doing, the one to check for exhaustiveness?
Yeah.
Like you have all the other simple stuff to do there.
Um. Okay, we are calling simple stuff is to do for other types, right?
Huh?
Okay, so which one do you want to start? So let's grab our, oops.
All the literals, right? Just choose one like integer.
Yeah, so, like that. Oops. And then we're gonna go to types. So all
Yes.
the other literals you said. So let's go up here. Okay, so t integer, t rational, t bool. Let's do t bool. That
Dude,
is easy enough. Okay,
man,
so
only
check.
the bool is different. All the other ones that are like infinite, they have the same implementation, which is always bad in Haskell, right?
Yeah, no, that always suck. So let's do the bool first. What should we do if you have a bool? So let's make the function. So if you are unsatisfied, right, and you have a p literal l bool with something, um, yeah, with a bool value, right? And then we're gonna do what with that?
Yeah. That is a thing, Lemus. Now this unsatisfied stuff doesn't work anymore.
Why? Go on.
Remember the part that I said that when you are matching finite stuff, you have to keep track of like what you already matched so you don't repeat?
But this is not infinite.
Okay, yeah, not infinite, but also anything more than one.
Mm. Okay, so we're gonna have to have a tuple of some sort here, I guess.
Yeah, actually, we need to think better about this because otherwise we do a bunch of silly instructions. Give me just 1 second.
So this one is the one that we need to think about the previous ones. That's interesting.
Come back.
Okay.
So yeah, well, we need to like some way to keep track of we already matched, right? Like otherwise, is there any way you could do that if you are not keeping track enough?
Yeah, so can you explain to me why do you need to keep track of this case?
Hmm. Let's suppose the first case,
Oh, if the
the first
first case is
pattern,
true and you have another true, you need to know that the true already appeared.
yes.
I think we can use a list as accumulator for that.
I'm not saying we don't know how to implement that. Like, as you said, just do a tuple and do, I don't know, at least what you already went through. But let's think about, right? Because otherwise we will do some shitty stuff.
Actually, not a list, a set.
not really.
Yeah,
Because
it needs to
when
be
you
unique.
find a duplicate, it's an error.
When you find a duplicate, it's an error. Are you sure? Is that how it works in F sharp?
No, 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 no. What I mean is, it doesn't need to be a set, because if you have on the list of matched patterns, and it is the same pattern that you have right now, you will not add anywhere. You will error.
Yeah, that's okay. The set will also okay works fine for that.
No, no, yeah, but what that means is you will never leverage the fact that it's a set.
No, yeah, in that case, I know that I will not leverage the fact that it's a set. I'm just thinking about the API, right? Because if you use a list, the find function returns a maybe, then you're gonna have to do a pattern match on that and etc. And I guess the set,
Find would also the find also always returns a maybe man. Doesn't matter the
yeah, I don't know
data
if
structure.
no, it does not.
Huh?
Yeah, the set, looking up a set does not return
No,
a
that's
maybe.
not a find. Find returns the element, not.
No, but do we have the same for lists? Only like a member? I don't think so.
If you don't, that's very weird.
LM. Maybe we do and I'm just not
But it
remembering.
doesn't matter, right? Like the find words just convert into a bool. Yeah, but I don't want to
No,
discuss
it
it.
does. It does. It does. So
Yeah,
you
but
get.
I don't want to discuss if it's a set or a list, but how it's a good model that works like in general, right? And
Yeah, that's a good
sure,
question.
we're probably not doing the best way, but let's just try to not grab the first one that we thought about. Uh, so, okay, the first thing I can see as a possibility is there are at least two possibilities, right? At least two cases in which we can do that. The first one is annotating uh, what we have matched, and the other one is annotated what is still to match, right? But that's, how can I say, that's kind of a lie, right? In
I
the
don't know what you
sense,
mean. Like, you mean like putting. What is the advantage of putting in the thing the things that we already don't didn't match, right?
yeah, I will try to reach
Because we
that.
don't necessarily will have a pattern match with all the cases, right?
What do you mean?
Yeah, because if you have a set of patterns that you still will match, what if you never match them, right? You match only one of them instead of the matching all of the remaining ones.
No, wait. We are talking about type checking, right?
Yeah.
So that's not regarding the one that will effectively match at runtime. We are talking about if everything is covered. They all need to be all covered.
What do
When
you
we
mean by
say
being covered?
by you have all the patterns needed for that data type. That's what we mean by match in the sense of static, right?
Yeah, but that's what I'm saying. You don't necessarily have all the patterns there in static type. Like,
That's the thing. If you don't, that's a warning or an error.
no, that's not correct. If you have
No,
only one pattern that is a catch-all, that's fine.
no, that's heavy now.
Oh, you're calling having it all having the minimal set of ones then.
Like being satisfied, right?
Yeah, that's not what I got from what you said before, but okay, now it makes sense.
It's because it depends on which pattern are you talking about, right? Yeah, I just have to pay attention here because you have to get food in a couple minutes maybe. Uh, but yeah, so the thing is, you are still keeping track of the thing anyway, even if you are saying that are the ones to they're all left, right? Because take a look, you cannot like enumerate the ones that are infinite, right?
Yeah.
So you cannot have a list of what is still to match. Doesn't make any sense.
Well, it doesn't make sense in the case of numbers, but it does make sense in the case of booleans.
No, yeah, I mean, as any infinite doesn't make sense, right? And then you could say, oh, it's just saying that it's lacking matching all. But that's still a lie, because you have to exclude the one that you've already matched, right?
Yeah.
So you would have something like, oh, what is the one that I left to match? And then you have something like, oh, everything except from, and then you list the ones that you match, right? So it is a lie. Uh, yeah, but what I want to maybe an advantage between those two possibilities is maybe regarding the sum types and nested shit. And let me see if I can try to put in words what I'm imagining here. Um,
Oh yeah, we need to keep track of the nested stuff.
it's very complicated, right? Um, and if Okay, so let's think about the case of nested stuff in which we are keeping track of the ones that we already matched, right?
Yeah,
So I will try to write in the chat a few examples because, man, it's just too hard to think about this stuff without like
that's fair.
annotation. So let's see. I will just like do the patterns here. Let's do with tuples, I guess.
Yeah, okay, that's okay.
I will write patterns here.
Yeah, everything aside from the unit is much harder because we need to keep track of stuff.
Yeah, let's suppose that's one. Right? Then that's uh, let's see. Something like this.
Okay, let me copy paste them and put it here.
So
Okay, so these are
let's
the cases that we are talking about.
yeah, let's suppose we have those patterns, right? Uh, of nested tuples and shit. So and then I have those on the list that I already matched, right? Of those patterns there, a list of patterns. And then, well, we don't even need the second, just the first and the last is okay to try to visualize that. So how do we know into the third one that like that's okay, right? This is okay.
What do you mean by the C is okay?
Uh, can I say? Uh, like it's okay, right? That would type check.
You mean the first C,
Oh
right?
wait, one second.
The one on the left part of the. Okay, one sec.
Uh, is anyone there?
Yeah.
Okay.
So the discussion that we are having right now is because on the case of booleans and stuff and nested patterns, we need to keep track of what are the patterns that we already meshed. Does that make
Yeah.
sense?
Yes.
Yeah. So we are trying to discover what is the best abstraction to tackle having nested stuff and keeping track of them. So because I suggested to should we can start with like a list of the patterns that we already meshed, and then we can derive the equality of patterns, and we just compare them. And Nathan was talking about something related to that. So and then he gave these examples here. So let's suppose that you have this as a pattern in like a tuple, in which the third member is also a tuple, and then you also have this. How these two will interact with each other. That's what we are talking now. And we are trying to talk at this right now because we're gonna be able to reuse this mindset for all the other ones.
Ay,
This feature is definitely I completely underestimated. There's no fucking way.
Seems too manual, man.
What?
It seems too manual, but I don't see another way to do it.
Yeah, it seems too manual, but we need to care. Like it's that's the thing. I can't see a way in which we don't do like, oh, for this type in specific, behave like that. For this other one, behave like that.
No,
And they
you
are
have to
different.
implement the behavior anyway, so it will be longer, yes, but ay ay.
Well, at least we don't have to do. I don't believe we have to do for like T abstraction and T application.
Yeah.
So some of them we're gonna just error out, saying that no, this shouldn't never happen, dude. It's totally crazy. The now that I think about it, like having pattern match, although it's a blast, it's a like it has some there it has its costs for the people implementing it. Definitely, it's not for free. That's sad. At least when we make it,
We
we're
do the
gonna
dump
also
now, and
go.
then we go adding later the rest because this is already a little beyond what we need to do. Why don't we do something like literal patterns?
What do you mean by literal patterns?
Like we did the unit. Why don't we do for things like integers or
No, but that's
whatever?
what you're doing. We are doing for the boolean, but the boolean you need to you keep track of
What?
the ones that you already meshed, right? Because if
Okay,
you already
fair
have
enough.
a true and then you have a true
Yeah.
again.
Yeah, yeah, I see.
Okay, Nathan. So which C are you talking about? The first one in the tuple there, or the third one in the second example?
I was talking about the third one. So, okay, to give an example, let's think about the simple case using listing the ones that we already matched.
Yeah,
So, for example, the boot that we are doing right now, we
yeah.
are keeping track of a list of patterns, a set, whatever, and then we just like take the pattern that we have right now. Let's suppose the pattern is a bool,
Mhm.
and we check is it in the list? If it is a problem, and that's it. That's the implementation. Really simple. But I don't know, and I don't think that works that easy regarding nested stuff. So we can just implement those ones in those simple way. And when we come to the nested stuff, we think about how to do it, right? If we find a good way, then if it's like generating stuff, then we can go back to the others
Yeah,
maybe.
let's do the Greg way first, and then when we discover something like shiny, then we go back and change.
Yeah, like all the literals one will work that way.
Okay, so if we find it, that's an error or a warning? Nathan.
That's a warning, I guess. We already covered a case like this. It should be the unreachable, right?
Yeah, that's my understanding, but I think Nathan said an error before. Is that right, Nathan?
Oh, wait, unreachable it's a warning, right?
Unreachable is a warning, but that should that be a warning or an error in this case? Uh, okay, so warning, and that's gonna be already matched. Oh, I'm gonna just put the same unreachable
The only case of error is the wrong pattern, right?
for the case being, yeah. Print warning and then just pure previous list. We're not gonna update the list. That's important. And then satisfied. Wait, wait. This is impossible, right? Am I crazy?
What?
Because we have a list and we are unsatisfied, right? If this if goes okay, this like how you are you unsatisfied if this member was already there?
I was thinking, let me describe the algorithm I have in my head.
Okay, go.
You fold on the with the same thing on the list that you have the previous patterns, and
Yeah.
then if you get an unsatisfied, then you check.
Oh,
It makes no sense to check something that is satisfied, right? Then
yeah,
it's done.
exactly. So
Wait,
if we
I'm
are
not getting
unsatisfied,
it.
yeah, let me explain, Nathan, to see, and then Magenta can see if I get it, if I got it. So we only gonna check this if here if we are already satisfied, because this then doesn't make sense if we are unsatisfied, right? Like, how can you go through this if this B was already there and you are unsatisfied?
Oh,
You
okay, folks.
No,
Satisfied and unsatisfied regarding have I covered all the patterns.
yeah, that's what
So
I'm.
just because I covered one doesn't make it satisfied. So I
So
use
wait,
it true.
dissatisfied is saying that this is matchable. Is that it?
no, this
No.
no the satisfied is we covered the minimal set of patterns for this type.
So
That's
in
what
my
the
head, it
satisfaction.
should have the cover the literal cases there as well.
Let's take a look. Suppose we use it true, right? Then true is on the previous list, right?
Mm-hmm.
Previous list. Yeah, so it is on the previous list. So just because I have true doesn't mean it's satisfied. So see, it
What
can.
I'm dude, wait. What I'm saying is even simpler than this. What I'm saying is like on line 12. Oh wait, 15 up.
15 up.
That is only satisfied because that's the only possible thing, right? On a integer, you should probably have like not a unit right there. That should still be unsatisfied on case of integers, for example, because it's infinite.
Okay, yeah.
Yeah,
But we
that
are
makes
only
sense.
checking for the opposite. The else is the one that you are saying.
Yeah, let me explain my GitHub to you. So we are checking here in this if
Mm.
to see if this literal that we are acquired from the
Oh, you're
one of
going
the
for the
patterns,
okay.
we are checking if that exists in the previous list of patterns, right? And then what we want, like the situation which is like no warnings, no errors, or anything, is the else, right? So this boolean does not exist in the previous patterns.
Like okay, but shouldn't a fold be enough to do this?
No, but we're gonna call a fold. We're gonna call this function here. But instead of unsatisfied, it's gonna be a tuple with an empty list, right?
Uh,
So for instance, here it's gonna be the following. It's gonna be this b column previous patterns.
Yeah,
Um,
now it's tricky because
yeah.
you have to check if it was satisfied.
Wait. What do you mean by checking if it was satisfied?
Uh, because see, you got a bool, right? And that could satisfy it if you already had true and the bool right now it's false.
If you already had true. Oh. Oh no, dude. Oh my God, you're
Gladly,
right.
that's only a problem for bools because if the thing is infinite, the only thing will satisfy will be the catch-all cases, right?
Yeah.
which is less bad.
Did you get what he said, Magita?
I wasn't paying attention.
Okay, so do you agree that if the boolean that we are in the pattern is not in the previous patterns list, we're gonna have to update the previous patterns, right? We are doing that with the commons there. But
Yeah.
that also means that we need to check our satisfaction, right? So, and how do we do that with booleans? You need to check if the opposite of what you currently have on hand already exists in the previous patterns. Do you
Yeah,
see?
that's yeah.
Or if you had a catch-all, right?
Yeah. So if lm not be
Oh,
in
no,
previous
sorry.
patterns,
Actually, the catch-all would generate a satisfied already.
yes, then we are satisfied. Otherwise, we are unsatisfied. Dude.
Dude, this will be impossible. Man, will be impossible to manage, man.
No, but no, we are getting there. Don't go crazy yet.
Dude, I have to do for strings, integers, man. This is
We don't have that many
How
types.
easy.
oh well. Integers and strings are always infinite, so you can always make a new
Exactly.
one.
Exactly.
But for example, think of you define a ADT, for example. Like it can be 3. You cannot do this. Like this is like a escape hatch.
We have different types of problems. You have the unary one, right? In which it's like the unit. You have the any case, in which n is finite, like that's bool, for example. And then that is the third category of the thing is infinite, right? And then that is more like, oh, and what about the things that are nested? We are solving one at a time. Like, we know that the nested case will be hard as fuck.
Yeah.
But well, we are solving the ones we know already.
No, okay, but what I'm saying is, like, if we're handling these already, like this, like seeing the specific cases, we could as well just handle the generic case of.
We don't know the generic implementation of it.
Okay,
Otherwise,
so that's it. I am giving up.
okay.
You're gonna give it up so just because it's hard? That's a bad argument.
It's not an argument, man. It's called being tired.
Okay, so what are the other patterns that we care in the case of booleans? We also care about the wildcard. Yeah, we are always gonna be tired on Nageta. That's our nature. That's a bad argument also, but okay. So this is gonna be pure previous. Oh, we need to check, right? Do we need to check?
What?
If we already got in. No, we only save the booleans in the list. Okay, so this is only previous patterns and satisfied. Okay. Next. Um, why that happened? I have no idea. What is the other one that we care? P variable. In the case of having a variable, we also gonna do the same thing, right? Wait, I lost hlint. That's kind of bad, but okay. Oh, why not? Okay. Oh, it is saying to be in fixed. That's okay. That's okay. Okay, so what are the other ones that we care? Nathan.
Not good.
No. We need to now we need to catch the guards, dude. Right?
Look, I forgot about that. Oh, that will be. Totally forgot about that. Let's see. Oh, dude. That will be a huge problem.
What?
Yeah,
Why?
that's a huge problem.
Why
Because
that's
take a
so
look.
huge?
Let's suppose you had true with a guard. Then sure, you could put the pattern true. But you are not saying that you still need another true without the.
Dude, that's what I'm saying. I
Or.
think it's easier to stop and think of a generic case before doing this. I don't see how like
Yeah,
just making these like special rules will be any helpful.
that's the thing, Magita. It's really hard.
Yeah, that doesn't mean anything. I know it's hard.
No, it is. It is. It is. It means something because if it is hard, and we're gonna block our, we're gonna not do anything else because we're gonna have to implement them, not the ones that we know anyway, right? Because they behave differently. The boolean behaves different than a unit, and they
But
behave
dude,
different than the infinite cases as well.
Lemus, I think that's a good case for the ones that are left, right? If you have the ones that are left, that solves that issue.
What do you mean? Can you
Uh,
explain better?
yeah, let me just like finish chew a few things here.
Okay, so Maget, I
what
agree
I'm
with
saying
you.
is the bool is the same thing as a algebraic thing. It is exhaustiveness on like a set, which is true in this case. I think it's easier to check the exhaustiveness of infinite first. So
Well, it is
like
not the
integer
same because
strings.
ADTs they can be nested. Booleans they can't be nested.
No, dude, ignore the case of being nested. What I'm saying is like simple things, like you have three, one, two, three, like option sum, whatever, like with literals in it. Like think of this case first, and then you go on that. Like what you're trying to do is just applying a bunch of like specific rules that will only work for bools. Like
But that's the thing. That's what I'm trying to say to you is that although I agree with you that we should try to think on a generic way of doing this, because it's goddamn hard, we're gonna be blocked for an undefined
dude,
amount
that's
of
why I'm
time.
saying stop and think for 10 minutes. If you
It's gonna
feel
be
like you
much more than 10 minutes, but okay.
if you think that after 10 minutes you cannot do any sketch of anything, then you do something else.
Okay, so let's think about that. So let's think how can we do.
So let's think of like our life algorithm. If you as a human being looking at the thing, how do you know if the thing is not complete?
Well,
So write an example up there. Let's think.
um, what do you mean with complete? Like,
Do a case first, and do I don't know. No, do a normal case in Haskell so the compiler helps us.
okay, so test v ma oh, case
You're being
v of.
brainwashed too slowly. Okay, annotate the t as how can I say, as a maybe.
Okay,
Maybe integer, yes.
and that's gonna return what?
I don't know, unit.
Okay, so then we're gonna do a just, and then something, and we're also
Just
gonna have
one,
a
just
nothing.
two, and then, yeah. Put it just one, and then just two.
By the way, Magita, I think what said doesn't work, man. Because you are
Okay.
talking about the general case, right? And then you say disconsidering the nested case, right? So if you disconsider that, you end up on the same kind of code that you are doing for the specifics.
What we are doing is not the specific, well, what we're doing is the specific for a primitive type,
Yeah.
which in this case you can abstract for a generic type. I don't see what you mean.
So you have the sum types and the nested cases, and you agree that there is some piece of code there that you hand the nested cases, right?
There's some piece of code there that you handle nested cases, like
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 this.
we don't know the implementation. That's the whole point.
okay,
But
like
we,
this. So
we
it could be a
know that.
maybe int.
Yeah.
Oh, you mean the examples? Yes. The examples, yeah. But I mean, on our Haskell code, we have some code to handle that, right? That's the code that is hard to write. Hard
No,
as
I'm
fuck.
saying ignore the fact that this can happen.
So that's the same thing as we are doing, dude.
No,
No, no,
dude,
no.
what the
That's
heck
not
are you
not what
saying?
what he's saying. What he's saying is, Okay, ignoring the fact that the things can be nested, can we try to identify a common pattern between different types for the behavior of checking exhaustiveness? That's the question. Mageta believes that the answer is yes, which is reasonable to believe in that. He just thinks that we need to spend 10 to 15 minutes only thinking and not typing, and we're gonna have an eureka moment about it.
Yeah, but think about it. How what we are doing doesn't achieve that. For example, we just saw a problem. What is the problem? The problem is our approach, our annotating into a list, everything that was matched doesn't work. Why it doesn't work? Because if I have a true with a guard, I cannot put it on the list, right? Because I still need another true.
Send me the
But
ST, please, Lemos. Can you screenshot it?
You want the EST?
Yeah, can you screenshot it, please?
Yeah, you can screenshot it. So types.
Although I have on GitHub, right?
Yeah, but here it is. Take a
Let
screenshot.
me pick it. Okay, you can
Okay.
guys can continue what you're doing.
Okay, so Nathan, Nathan, you are muted. But let me try to explain to you, Nathan, Mageta's philosophy, because this is a clash on philosophy, on like a principles. Because what we are doing, Nathan, we are doing the Grug way, which is to do it in a dumb and naive way first, and try to identify patterns. And what Mageta is doing the like reverse Grug, because he's doing, let me pick a piece of paper and a specific time window, and let me try to figure out by myself, or like an abstract way, what is the pattern that I can apply to solve this problem. So it's the like it's the literally the opposite of the Greg way, which is fair. I'm not saying he's not gonna accomplish that. I think it's complicated to do it is if the feature is hard as fuck as this one. So that it's a totally clashing philosophy principles. But going back to your question, Magita, how do we know if the thing is infinite or not, right? Just by looking at it.
Well, that
We
I
use this
think you need
function.
to. Yeah, I think you need to define, right? Because it can only be infinite if we don't have dependent types. So I don't think
Yeah.
he can make alias or make an infinite set.
Yeah.
So it's only like primitives that can be infinite in our case right now. Don't have recursion as well to generate this.
Now the easiest way it is to just type this function.
Yeah, I think so.
So if you are an integer, rational, or string, um, dude, Emacs. If you, let me take a look on the types again, just to be sure. So integer, rational, string, list. List is kind of infinite as well. We're gonna ignore the arrow. We're gonna ignore the type variable, the for all, that application. Dude, I think we wait. Am I saying crap?
I don't know what you're saying.
We care about the anonymous record. We care about the list for pattern matching, right? So T unit, T integer, T rational, T bool, T string, T list, T anonymous records. These ones we definitely care. But from the special ones, I think we only care about this. Is that right?
Wait a second, because I was not looking. Dude, what the heck? Okay, say it again, Lums.
Do you agree that for pattern matching, we only care about these and these?
Uh, yeah, T variable we don't. Yes. Arrow as well. Yeah, from the record above, yeah.
Yeah, so yeah, this is not.
Algebraic as well, right?
Yeah, no, I am highlighting this because it's all of those and this.
Mm-hmm.
This is not as hard as I thought because half of the types will not be used.
wait, No, actually, that is something interesting there. Maybe, and that's a huge maybe, the type variable is a valid one if I only use the pattern that are generics.
How the heck are you gonna pattern match a type variable?
No, not pattern matching a type variable. Something that has the type variable, right? So try to do the identity with the pattern match. You will match what you got and just return it, right? On one range doing the
No,
bind
but
of a
let's okay,
variable.
but let's do that later. I only want to identify the ones that we need to care about and try to say which ones are infinite and which ones are not. So the T-bool and the T-unit are the only ones not infinite. Everything else, discarding discarding this, everything else is infinite, I guess, because they are using lists, or they have sets of infinite stuff.
What do we have in our branches? It is three things, right?
What do you have in the branch?
Yeah, and
We have
what
a
is our branch?
pattern, a guard, and the branch itself, right? So the expression that goes after pattern match.
Okay, so a pattern I have here, I guess.
Mm-hmm.
Yeah, pattern.
Yeah, I have a really hard time trying to see how you're gonna make it generic because they work so differently.
No, I don't want to make all of it generic. Like for example, the records, I don't think we can like extend the same as for the others. But for the primitive types that occur, like for example, I think the literals for strings we can do already. Because it has no checking, right? It's just like, okay, you see the previous pattern, it's never exhaustively, like because it's infinite. So you don't, for anything you do, like it doesn't matter. It's not gonna be exhaustive unless you have a wildcard.
Okay, let's do the infinite then.
A
Let's do
wildcard
an
or a
example
variable, I
with
guess.
infinite. I want to do an example with infinite. So let's
So let me
do
see.
the for an integer.
Okay, so let me see
So
if I
t
can think.
integer list. So
So wait, why a list?
well,
List of patterns.
because
Oh,
it's a
those are
list.
branches.
Yeah.
These are the branches. Okay.
Yeah, the branches are composed out of a pattern, a guard, and a branch.
So okay, if it's still unsatisfied and you get uh, a wild card,
Satisfied. If you get a wild card. I'm gonna put the case without a guard,
hmm
and we ignore this. Then the answer for that is I am from now on satisfied.
yeah.
If you have
If you have this,
as a variable name, this you also.
don't you need to check if the oh man, wait. In this function, you don't need to check the the guard as well to
No,
know
we will
because for
check the
example, you
guards. I'm doing the because there are two separate concerns here.
yeah,
There are the
wait.
concerns when we don't have guards,
um,
and they change when you have it. I'm making the easiest ones first. But dude, we have a gigantic
Because here's
problem.
the thing I mean, like the guard also influences. Like if you have a wild card, only one, maybe yeah, okay. If you have only one, but you have if you have like I don't know if um X, I don't know, man, something that is always true, then that's satisfied.
No, but that's the thing. You don't. We are not. Wait,
Like
but do we? No, we can't.
when
We can't know that information, Magita. We don't know if the
well,
guard will be
w-
true.
well, you have the value, but
But
this
this
is
is
type.
type checking.
Mm-hmm. Yeah, I think in this case you can't because we need to evaluate
Yeah, we would need to
the guard.
call the evaluator inside type checking.
Yeah, no, you cannot.
That's like runtime whatever.
Let me
That's
see
like
what F
Rust
sharp
stuff.
does with this. That's interesting. I think it just will launch a warning anyway.
Okay,
Let's
but
see.
there's a problem, dude. There's a problem. There's a fundamental
Mhm.
problem that I see. Having the list of previous patterns is not enough because we also need to take care if you already use the name of that variable, right? So if you have an x and you have another x there, that was already like you already
You,
used that name for the
mm,
stuff. But in
Wait,
that
for
case,
different
wait,
branches,
I
you
didn't get
don't
the.
care.
yeah, that's what I said. That's what I was about to say. If you have two names, but because we don't differentiate them in any manner, the first one will satisfy, and then the second one we're just gonna say unreachable whatever. Okay, so that works.
Okay, yeah, F sharp it marks as a incomplete pattern matches. Although I have a guard that is like true.
No, because that is doing compile time stuff. Like that
No,
would
no,
be
no, it is not. Like it is just not looking at the guard at all. Like
no, but that's the
the-
thing. Discovering if a guard has the value true or false, that is
yeah, that's
runtime
beyond the
stuff.
types. Yeah, I know. That's what I'm saying.
Okay. Now these are the easy ones. Now we're gonna go function,
I'll have
function.
dinner. I'll be back.
Okay. Previous patterns unsatisfied.
Just type this.
Now you're gonna have a p literal and then an l integer and then we are gonna have a number here. And then Nathan, you were about to say something about if we pattern match the boolean but we are having a guard that changes something. I remember you was talking about that. I would be interested to know guard. Right. So what we're gonna do about this, right? What we're gonna do about that? Do Okay, now the question becomes, do we save stuff if we have a guard?
That's the thing, Linus. You can't.
I can't save stuff.
Yeah, because suppose you have a true with a guard. You cannot say you match the true because you still need one true without a guard.
Okay, but if that's the case, that's easy. I just return the same thing besides unsatisfaction, like that. But if you have a nothing, then we do the logic that we did up there.
Wait, let me
If number lm previous patterns, um,
Yeah,
then
that's true.
print warning, warning, unreachable.
That's funny. Like the guard just invalidates the.
Yeah. So then pure, and then we're gonna just put the same previous patterns, and then unsatisfied. But else, we're gonna do something really similar to that. So I'm just gonna bring it over. So we don't have b here, so this is gonna be a number. Okay, then there's the question, right? If the element is don't have this condition here because this is an infinite stuff. This is always going to be unsatisfied, right? No, satisfied. Sorry. Does that make sense?
What?
Let's suppose that the number that you are providing me in the pattern match is not in my previous patterns list. I'm gonna
Yeah.
save that down and I'm gonna say that I'm satisfied.
No, no, it's always unsatisfied, right? It's infinite.
Oh, okay. Okay, no, it is always unsatisfied. Yeah, that makes total sense. That makes total sense. Okay, now we go to the previous
By the way,
pattern.
there is a bug on line 20 up, I guess.
20 up. Why there is a bug there?
You are just putting satisfied without checking anything.
No, but it's already there. This then is when you already have the
Yeah,
previous.
true twice doesn't mean satisfied.
Oh, I need to do this if then, right?
I don't know, but you have to check if it is satisfied, right?
Yeah, so it is this if. You're right. Yeah, you're right. That was a problem. So I want to do now. This is the older case, right? This is only the older case. If you are unsatisfied and you encounter anything else than that, that's an error. And we need to do here. That's an error. Type error. Couldn't satisfy. Couldn't match actually. Match shoulder. Okay. Now for the final case. Now for the final case. Yeah. Which is that you have previous things, but you are satisfied, right? This is just a warning, correct?
What? Not keep following.
I didn't listen what you said.
Not following.
Oh, okay. Warning, unreachable, reachable case, and then we're just gonna return pure previous patterns. I have a question for you, Nathan.
Wait, you still need to fix the bug regarding the wires, right?
Yeah, I will do that. I just want to ask you something. I want to ask you something really, really important.
Mm.
Right. Do you agree? Do you agree that aside from this name, we should be able to reuse this for both integers, strings, lists, and rationals?
I have no idea about lists because,
They are
well,
infinite.
yeah, but in a different way, I guess.
Yeah, but
Especially because they generate stuff, like they generate binds and yeah. So I wouldn't say anything about lists. I wouldn't.
yeah, okay.
But regarding the others, they have the same code,
Mm-hmm. But just
exactly the
change
same
this.
code. If you can actually write the code to abstract that,
I think
I
I can.
guess you can, right?
Yeah.
Yeah, maybe you need some functions to test stuff and to convert stuff, but I guess you can.
Yeah, I think we're gonna use this function that I made during the explanation to Magit. But that's something for later. I want to see if everything is okay here. So now that's where we go and bring our satisfaction back to this. We copy paste this code. We put it in here.
Let me see. So satisfied, wildcard, nothing, just litro with the ward. Wait, that does change something. That changes if you're adding or not in the list. If you have a guard or not.
Yeah, the guard changes that. We have a problem because it's saying that I am shadowing something, and I don't know where I'm using the word guard. I'm using it only twice. How am I shadowing? That doesn't make sense.
So yeah, the line 6 down, you have to consider the guard there. Oh, maybe
Six.
something that you are importing from some.
Yeah. Which line?
Uh, the one down.
One down. This?
Yeah, you are always including the number in the patterns, right? You need
Yeah.
to change that based on the guard.
No, but we know that the guard is nothing.
You don't?
Yeah, I do.
How?
Because I am testing exactly that.
Oh, yeah, still sorry for that. Uh, yeah. Yeah, I think that's right then.
Yeah, this function, it is totally
If the
uh,
element
abstract, like possible to abstract it out for infinite stuff.
is on the previous part. Yeah, take care of the infinite stuff, right? Infinite primitives at least.
Infinite primitives, yeah. I don't know. We have to think about. My opinion is that lists, records, and ADTs, they have some infinite aspect to them, but I don't think they will use this sort of this function here. Okay. Okay. So let me think. Let me think. Either left. Oops. Are you still using? Yeah, we are.
Yeah, then the is infinite doesn't make sense anymore.
Let me think. Let me think. I need the type of L integer. Oh, it is broken. That's cool. Ambiguous of. Oh, there is a function in the prelude called that. Dude! What the? Is infinite. You gotta be joking, dude. Primitive. Um, Primitive. Okay, I still need to go to this guy. What is the type of that? It picks an A and returns a literal. It picks an A and returns a literal. L integer, L rational, and L string, I guess.
What the fuck, dude?
I'm trying to abstract the thing out,
That
trying
is
to return
something
a function.
really weird. No, no. Why isn't that just a type length?
But no, because I
Why do
based
you
on the
have
type,
H literal?
because the type itself does not tell us which function needs to go here. Which constructor needs to go here.
But man, like any of the primitives takes anything. That's the whole
Any
point of
of
being
the
a primitive.
primitive takes anything. Yeah, that's exactly what this says. L integer is a function that if you give me A, in the case of A being an integer, I will return you a literal. That's what it means.
Oh, wait. Why? Why is an either type? Oh, no, no, you are not returning a type, right? You are returning a. Oh, I see. You are returning a literal, right? Now I see.
Haskell is not happy about that. It's saying that expected type to be an A, but the actual is actually an integer to literal, which is correct. Which is correct. How can we abstract this thing out? Do we have? I think we're gonna have to make another auxiliary function, I guess, to decipher which constructor we should use here.
Can you let me see the definition of those literals?
Sure.
Ah, oh, 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 oh.
Hello,
Oh,
Nagata.
Mm,
oh. I see. Yeah, I don't think you can type that, dude.
That's unfortunate. That's phenomenally
Yeah,
unfortunate.
it's really not H literal. Like you cannot take anything.
No, I am taking anything. Or sometimes it's an integer,
No,
sometimes it's a
no.
rational, a
What I mean,
text.
everything. Right?
That's
Anything in
fair.
the sense of any A, right?
That's fair. That's fair. How are we going to decipher which one should be here? I never did this. We want to pattern match something, and the construction of the pattern match is something that depends on something else. That is, I never did that. Never. Let me try to explain to Margareta what we did, okay? So Margareta, are you there?
mm-hmm.
So we finished the function, right? So this is the function for the integer. And you were right in the sense that this function is the same regardless if you are an integer or a rational or a string.
Well, there's nothing different in both ways.
There is something different, which is this guy right here. So then my idea was, okay, that's okay. So I'm gonna create a function. Oh, let me explain. So what is this L integer, right? Do you agree this is a constructor that
Mm-hmm.
picks an integer and returns a literal? Do you agree with that? That
Yeah.
something that picks
Okay.
an integer and returns a
Yeah.
literal?
Yeah. Mm-hmm.
Yeah. So, but the problem is that we want to be able to change the constructor to pattern match, right?
Yeah, that is another problem, Amos. You are
Wait, but
adding number to the
yeah, but
patterns.
no, yeah, but I'm gonna change this name when well, I would be changing the name.
Not the
Anyway,
name the problem.
so not the, Magetta. This constructor here is the only thing that we need to be able to abstract out in
Mm-hmm.
order to make this function completely reusable for both strings, integers, and rationals.
Yeah.
The problem, well, and then I said, okay, so I'm gonna give you a type, and you're gonna return me for me one of two things. Or you're gonna return to me a type, which that would mean that this is not infinite, or you're gonna return to me a constructor.
Yeah, I would say why then it should pass a function and don't pattern match there, but then the function pattern matches and returns the value for you.
I don't know if I got it.
Like you just need the number there to do the special
Dude, this
case.
LSP is so much worse. It's not the deducing, like deriving the type by itself. I need to change that back at some point. But go on, Magetta.
Can you go down the literal example?
The
Uh,
literal
the thing you did there, down there with the literal.
Oh, here.
So the only thing you do is you pattern match, get the number, and then you just do if the number blah 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 is an element of the
No,
previous
we do
pattern.
two things.
Mm.
Nathan discovered that we can, if we don't have a guard, well, the opposite. If you have a guard, which means that you're gonna pattern match and just, we're gonna do something else than if you don't have a guard. If you don't have a guard, you're gonna go this if. But if you
So this no okay, but this is also specific. This can contain specific behavior as well, right?
no, but that's the thing. We talked about it, and as far as I can tell, this is the same behavior for both rationals, integers, and strings. This function here.
You
You're
just
gonna
need to change the L integer there.
Yes, instead of L integer, it's going to be L rational and L string, and everything else will be the same.
Oh, dude, can you copy? I cannot go there. Can you copy, paste somewhere, and then just send instead of doing L integer there, pattern matching, you pass a function that you receive like a literal, and then it does the pattern matching inside, and then it returns the thing for you, the number,
Yeah, but
the
what if
string.
it is not the what if
Oh,
it's
then
not
it's a do, right? And then you fail.
no, but this is before the do, dude. What we are doing here is before well, we have a do here, but that's not the point. This function is being used in a fold. So I don't know how we're gonna abstract this constructor out. I never
Wait,
had to
the
do
pattern
this
match
before.
is just to okay, don't enter on this case, go do something else, right?
We No, this pattern match is the opposite of that. If you
No,
pattern
wait.
match, in the case
Mm.
of a t integer, you pattern match a literal in which the literal is a number, an integer as well, then you're gonna check if you have a guard. Then
Yes,
you're
dude,
gonna
I don't see why this cannot be a function.
no, but we are trying to make one. I started like, do you remember the view patterns that we used, right?
Yeah.
So my idea was imagining that this would work, right? Imagine for a moment that this is working just fine. So we are returning a constructor in the on the left of the either, and if you're not in infinite, we're gonna just return the type itself on the right.
That's that's the other thing. I don't see why you are returning the constructor. You should just pass one constructor there. Construct, not even constructor, just a function that does the pattern matching for you.
A function that does the pattern
Like,
matching for me.
okay, write type like this. I think it would be easier to explain. Like I don't know, test whatever, and then you do what do you need to do there. You receive. Uh, okay. Did you,
Wait, I'm still waiting for the example. I didn't get it what you
okay,
said.
go up there, like on line 7. I don't know.
Line 7 what?
Yeah, up, down,
Up.
up, up.
Okay.
Yeah, there. Do it like a function. I don't know, ABC.
Hmm.
So the ABC will have just the a literal, and then it replies what you want, which is a generic. And then what this function does? Well, you can construct a function that, I don't know, picks a literal that we are gonna pattern match. So this should be lambdas, right? So that's what I'm saying. So yeah, it's like integer x, and then what you return on that
Is the X.
is the case guard, blah blah blah, all of that.
Is the case guard blah blah blah.
Yeah, which can be another function inside
Yeah,
of
that's
it.
okay. I'm not seeing how we're gonna use this function here because we are only using the L integer for pattern matching. That's the only use case for it.
Yes, that's what I'm saying. You remove that, and then you put x, and then you do, and then you call that function, and the function returns the same thing as that one.
Wait.
Like from line 1 up to line 4 down. This would be the function inside of it.
Okay, so whatever you're talking, we are talking about having a function that receives a literal. It receives the guard as well.
Yeah, the result. Yeah,
It also and it will return the same thing as we are returning right now,
which I don't know what it is.
which we don't know what it is, but that's okay. That's totally okay. It is a result T of a tuple. This tuple is a list of something, and it is as well a satisfaction status. So what you're saying is that if you have an integer, we're just gonna do this.
Oh, it could be not necessarily just integers, right? But the same.
Yeah. I don't know if what Haskell will say about that A that I put it there. Let's see. So let's suppose that you have something like this.
Oh, I need the other
You
garbage
need
as
to
well.
you need to receive the previous state as well. So alongside this, alongside the guard, you need to receive the previous accumulator. So you need to receive that. So you have the previous patterns. You have the guard. Then you're gonna do X, X. Yeah, we have a problem here, you see? What is the
Mhm.
problem? The problem is that the list of A's, right? The list of A's is not necessarily going to find an integer there. And the X on the L integer forces it to be an integer.
Yes, but that's the point. Like the we should eliminate the pattern match and have this as a sub function inside of that, not as a function, because then it will call
Yeah, then I'm
the
totally
restriction.
confused. Then I'm
Like what
sorry.
the problem is, the restriction will enforce this function to be an integer, right?
Yeah.
So we need to find a way to make it also generic. So, okay, but this is already better because if you need to duplicate, you just copy paste this guard and then you just call it there. Yeah, you just make a lambdas with pattern matches that you want, and then you just call it there, and the rest is the same.
Yeah, I am totally lost in what you said. I'm sorry.
What I said is from line 10 down to line 20, the only part that would repeat over and over again is the 15 to 20. The
No, no, no,
rest you
no,
can
no. That's not the
reuse
case.
it.
That's not the case. All of this block repeats for the cases that we are talking about, right? So this
No,
entire
dude.
thing, all of
Yeah,
these
but
repeats.
okay, but this could be a function. The part that we need to specialize is the 11 to 6 in that case, if we cannot do the restriction problem.
Yeah, I don't know. I don't know what to do because you're talking about. You said something that I agree. We need to make this generic because this thing is enforcing something that we don't want to enforce. But I don't know how you're gonna do that. I have no
Let's think.
idea how you're gonna do that.
I was thinking of doing lambdas, but then this case inside the lambda would be too big. Like a do and then a lambda, you see? And then you invoke the lambda with the x there, with the L integer in that case.
You evoke the X.
You just need to get the thing inside, right? That's all. So what I'm saying is, you just need to pass one parameter. You don't know, this guard could be a function that receives x instead of receiving a literal. So receive is change literal to a.
Change literal to A. Sure. Hmm.
Now remove this and
Mm-hmm.
put just x.
Mm-hmm.
That's it, isn't it?
No,
What is
totally
the lane?
not.
What's the lane problem?
Let me try to explain to you the problem again, because I don't think you got what. Let me try to explain the algorithm again, because I think you're gonna get the problem. Okay, so let's go to the integer again here, down here. So let's suppose, right? So what we are doing here, so we have a fold. This fold will pick the list of triplets. Each triplet is contained of a pattern, a guard, and a branch. And we're gonna fold it using two things. Our satisfaction level, satisfaction meaning we
Eliminating the
already
previous ones and knowing if you finished all the possible
the
things to
required
match.
ones.
Yeah, the requirements are
Yeah,
or not.
yeah,
You don't miss.
exactly. And then this function here, remember we pattern match with an integer up there. So if you have a wild card or you have a variable, those are the easy ones. If you have guards, this always will give you unsatisfaction.
Yeah, this part I get. And then the
Then
guard you say
yeah,
you check
yeah,
if
so
there is a guard. If there is, then you just return the unsatisfied because the guard is not sufficient to make
yes,
sure that you have a generic case. And if you don't
yes,
have a guard, then you see if the element is inside the other patterns. If it is, then this is an unbreachable case because it's being previously defined.
yes.
Otherwise, it's just cons and then continue.
Yeah, then we just say that. Oh, and that's the important thing. In the case that we don't have it, because the integers they are an infinite set, we
Yeah, you
always
just
gonna be
continue because it's
unsatisfied. The only
unsatisfied.
way to be satisfied is if you use a wildcard with no guards, or you
Yeah,
have a label with no guard. That's the only way to not to be satisfied when you have infinite sets.
yeah.
Okay, so what is the problem? The problem is that what we want is a way to identify that we have something and get what is the inside that pattern, right?
Yeah, these you can do with pattern matching. What I'm saying is like you only need to abstract the guard there.
You only need to abstract the
Like
guard.
go up there. Go
Yeah,
up
dude,
there.
I don't think we're
Dude,
talking about the same
no,
thing.
wait. What's wrong on that lane to begin with?
Well, because this is a list of A's, right? So
Yes.
let's check the LSP itself. So what is the error here? Okay, so no instance for equality. So in order to have a lamb, you
You need
can
to
do
enforce something.
A and you can do that. And
Okay.
now it works.
Okay, so you already can eliminate line 12 to line 17.
Sure. So let's call this function. This is a hard one to name.
Uh, Let me come up with a
um,
Java name. Infinite, infinite literal pattern result. I don't know.
infinite result.
Yeah, okay.
Okay, so then you're just gonna, instead of calling all of that, you're just gonna call infinite results. You're gonna
Number.
pass the number. You're gonna pass the pattern, the previous patterns. You're gonna pass the guard, and that's pretty much it. Then we can remove all of this.
Okay. So now the other problem is how do you abstract this function, right? All of this.
Yes, that's what that was the original problem. Yes.
Okay. So let's think. We know all of the types uh that will be, how can I say? Um, yeah, okay, I think we can do this. Because we know all the types that will be infinite. So can you copy this let line 4 up to line 2 down?
Wait, you're talking
Like
about
take
these?
this function outside, yes. No, no,
Take
yes,
this,
all of this block.
all of
All of
this
this
block.
let. No, no. Wait, is this case inside of it as well?
Yeah, all of this is reusable. That aside from the L integer, everything
I would
is
say
reusable.
just copy the function outside first, and then we think of what we do with the rest.
Well, sure. So I don't know why we're gonna do it that way
No,
because it
no,
sounds
dude,
harder, but
all of
okay.
it. All of it.
Oh, all the function.
Yes, all the patterns. Okay, let's annotate first to think. So what does this function do?
Uh, wait, we still
Oh,
have one example, one space there. So this function does the
hmm,
following. It picks a tuple. It picks a list of,
list of A's.
in this case, a list of, not an A's, because this we are using L integer there, so this needs to be an L integer, a list of integers,
Wait,
and a
wait, wait,
satisfact.
wait. Okay, this specific function, it takes an integer.
Yeah, and then
Okay.
we also gonna have a triplet, which is a pattern, a maybe expression, and an expression itself. And this will return a result t of a tuple, in which we're gonna have the same list of integers, and we're also gonna have a satisfaction.
Okay, you can already change the integers to a again.
So a,
A, right?
oops, a, okay.
Okay, now on line 4 down, you
Mm-hmm.
can remove the integer, like the integer number, and just put value. I don't know. And then you pass value to the infinite result. Yeah, okay. And then on that function, we do the pattern matching.
On the function infinite result.
Yeah, which is just like 4 things, I guess, right? Rationals.
Yeah, I think we're gonna get to the beginning again, but let's go. So what the type signatures have to change. Do you agree?
Um, yeah, to change to literals, yes.
Okay. So do you agree that you're gonna have a literal here?
And then you dismember. Yeah, it's fine to me.
Okay. So the question is,
The first thing, you just do the pattern matching. No, you
okay.
can do a quiz, I guess. Let me see.
So L integer x.
Oh, wait. Because one spits an integer, another spits a literal, sorry, a string.
Yes.
So how do you capture all of this and abstract this case as well? That's the problem.
Yeah, but that was the original problem. That's what I'm trying to communicate, but I failed.
Mm, dude, we can do this, but
I have no idea how.
let's think a bit. I think. Okay, can you show again those like view patterns? I don't recall how they work.
Yes, so the view patterns, they apply a function and then you pattern match on the result of them. So in the case of on this, we are grabbing this type and we are applying to this function
So
and
we
then
can use
if,
them, I guess.
sorry?
So we can use them. We just need a function that picks the thing, like the pattern we want, which is like an integer, string, the
ABC,
one.
It picks a
Oh,
literal and
but
returns what out of that?
my only problem is that will be. Oh man, I don't think so because it will be like different types, right? So the
Yeah, exactly.
can we even do this then?
Yeah, that's that was the point.
Do we
Uh,
have well, you can wrap in an IO, I guess, right? Can you?
I don't think that's gonna work also, even
I
if
don't
I
know
wrap with
how do you
anything.
box stuff and lose the type like a object in F sharp.
Yeah, that's the problem. I don't think we have that capability of having the object
Oh,
stuff
that
there.
sucks then.
Yeah, no, it is the one time having something like OBJ is useful. So that's the thing, right? Um,
Yeah, you need to duplicate all of this garbage. I think you can only the only thing you can do is always just remove functions and try to duplicate less, which we did, I guess, but it will
no, we
still
did. That's why
require.
I didn't insist on not following what you said. I think that you did a good thing. But I knew that we would hit this whole roadblock here. But I liked this abstraction thing that you did. So that's why I continue with the
At
thing.
least down there it will be less stuff, true.
Yeah, I
Paste.
will ask. I will ask people about this thing because I think it's super interesting. The fact that what is it complaining now? Oh, okay. It's actually complaining about the A stuff here
I mean,
because I
types are
never
just in the way, man. Just remove them.
types are in the way, right? Types are indeed in the way. So we have this function here, and then as you said, it's gonna be way less. Uh, I still don't know why we
I guess
left
that's
this
the case
out
for.
of the
Oh,
abstraction
wait,
there,
wait, wait,
but
wait, wait,
okay.
wait, wait. Isn't that a case for a for all?
That's a
That's
good
a
point, right?
that's a polymorphic function, right?
Yeah, that is a polymorphic function. I don't know if that's gonna
How do you
help us
do a
at all.
for all in Haskell? I have no
You just
idea.
type it for all a
Oh, okay.
that. You need to probably put the some
Check
rank
the
and
syntax.
types. Rank and types. Oops.
Let's
So
see the
rank
syntax.
and types.
Haskell for all. Explicit universal quantifier. Yes, it is for all, blah blah blah, and then you can do your stuff. Yes, it probably just need to import. Okay, it works, right?
No, no, no.
Oh,
It
you
is still
restarted. Oh, that's
using the
good.
version with integers, right? So
Mm,
let's try to do what you said. So this is gonna be a literal. I don't think that's gonna work for us, but we can try. So L integer. Yeah, it is still complaining here saying
wait.
couldn't match expected a list of integers and actually we have a list of A's.
What? This is strange.
No, but that makes total sense because the list of previous patterns is a list of A. But X is an integer. It's not any A. It is integer.
Okay, but the literal should have an A inside of it as well.
No, but to
Oh, I
do
see.
that,
The problem is that the A needs to be the same thing as the literal blah blah blah, right?
yeah, something that we could. No, I don't think we could. Yeah, I don't think we could.
Can
But
we remove the literal from that, from this function? If we can, I think we can do the for all there.
no, first things first. Haskell already puts when you use generic types on Haskell, it already adds like a for all implicitly. So you actually don't need to do this. I don't know the cases in which you have to type. You have to force it. I don't know that. But what I do know is that you're talking about putting the thing here, right?
Yeah, like what we were trying to do, but then because we need to pattern match anyway. But I wanted like to be able to ignore the fact, the little inconvenience that all the types would be different, but we have to pattern match anyway.
Wait a
So
second.
that's unless we do another function that this could be a for all. Yeah, okay, I think we can do this, but then this function would need to be. Yeah, dude, this sucks because another function that returns like.
Ooh,
Wait, what happened?
there is something that I didn't think about. What if we do like that? Instead of having a list of what is inside, we do
Okay, just
a
go
list
back
of
to the same type.
literals. And
Yeah,
because you
okay,
can
then it's the same
derive,
type. Yeah,
you are
it's then it's
storing
the same type.
patterns. You are storing patterns. Yeah, that's fine. I think that's still fine, Nathan. You know why? Because the derive will it will match the outside pattern, like L integer, and the content inside. But this is worth a shot, though. This is definitely worth a shot.
Yeah.
So let's make infinite primitive because I removed the function. And
Dude,
let's
that's
just
a
see.
golden rule that I forgot. Because whenever I felt the need of doing something polymorphic in F sharp, I just said, I just need to make another type and cast it up. And it always solved my problem. Well, at least what I did. And it solved it again. Like,
Left and t integer, and then we're gonna just repeat that 3 times. Type prime, right, type prime. Oops. So t rational, t string. So t rational. Oops.
why don't you use integers to signal this in
You.
I'm just joking, by the way.
So this string. Okay, so now, wait. So let's suppose that you have a left. If you have a left, you're gonna call this function. So we can delete this, all of that. Yeah, all of that. We don't need the type. That's so weird. We don't need to pass the type to this.
What is the type to begin with? I don't
It
even.
is the type like t integer, t
Oh, to that
rational.
one, I don't think so.
We don't need to pass.
Patron. But
That's
wait,
really
how?
weird.
Okay, we can just do the Elaine because the literal has equality implemented, right?
Yes.
That's the only.
So let me try something else. So let's suppose that you have check exhaustiveness, and then the is infinite primitive throws us a right. Right. So then, wow. Wait, then we could just do t unit, I guess. Oops.
Oh, yeah, that's the only thing we have right now, right?
Yeah, and then this. Okay, this guy. What is the problem with this guy? Parser error or unsatisfaction. I have no
Space?
idea what you're talking about.
Isn't it space? Oh,
Oh,
we removed the do, I guess.
yeah. And then we do the same thing for booleans. Uh, so tbool.
Yeah, the code is already better. I can read at least.
I don't know about that, but okay.
Oh, there. It's not. It's better doesn't mean it's awesome, right? But
And then we can just drop this guy. Holy crap!
Yeah, that's better.
Huh. So let me see if I got it. So if we have a left, that means that we have an infinite primitive, which is kind of ironic, right? Because it should be right this, not left. What is the type of previous patterns? It is a list of literals.
There should be patterns, right? Not
Not a list
literals.
of patterns.
Yeah, the previous patterns are not patterns.
Um,
Because if you don't on those previous patterns there is a wildcard, for example, then it's over, right?
I don't know if we this should be list of patterns, but I'm gonna do what Nathan is saying because he knows more than me. Uh,
Yeah, but
P
we are not using it.
literal.
Yeah, in this case we always know it's a literal. So
Yeah. Let's. I don't know. Pattern. So this is gonna be P literal X. Wild. That.
don't you need the in?
Yes. And then pattern.
Let's send something here. Well, that's more generic. It might help you. What is the type of
Yeah, now it is. It is what it is. Dude, that's wild. I'm really surprised that we don't have to pass the type to any of the functions. That's so weird.
Oh,
So weird.
it's there actually. It's on the literal, right?
And let me change this. This
On
should
the
be
act.
right, and this should be left.
Imagine having to think what is right or left.
Yeah, the right is right. That's the joke. That's the
Yes,
the
I
perp.
know that that's good.
The right is right. So
What is that 22 to 33 on the bottom?
what the where?
On the bottom of Emacs, like what is that? Like
I have no
22,
idea. I
33?
have no idea. This is your config.
What the heck?
Yeah. And what is
Oh,
this empty
press,
character doing? Oh,
press
Control
Ctrl
G.
G. Yeah,
Okay, so we made a way.
compiling this.
We made a way. Okay, I also want to make check satisfaction. Um, which picks the satisfaction and returns a result t of that. And then it's going to be basically this code. Satisfaction. Yeah, like that. And then we can just check and fmap that.
What is wrong?
Good question. So we need to discover what happens if I do +1 fmap in a tuple. Okay, it does things to the second. Oh, but we want to ignore the first thing, right? Okay, that's kind of sad, but okay. So we're gonna do that. We're gonna pick the satisfaction. We're gonna pass that there. Yeah, that's still wrong, but we're getting there. Just look like that. Okay, there's a type problem here. The same blah 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 blah. Oh man, I have to. I hate this in Emacs, but okay. So what we need to do is ignore that, pick the satisfaction out of it, like that, and just return check satisfaction. Satisfaction. Okay. Okay. So what is the type of this FODEM here? Why is it not telling me?
Oh, it is.
It is
Egg.
not.
Oh, isn't it that egg? Oh, that's totally screwed up. Can you
Oh, there
pick
is a
your
near. No,
mouse?
there is a type problem here because we don't have
Oh,
list.
I see.
So what is list again? Oh, list is the list of triplets. So it is that. It is this, right? What is the problem now?
I need to pass it, right?
Oh, I need to pass it. Yeah, that makes sense.
A second.
There. There. Okay. Okay. There's a better way of doing that. Satisfaction. We put this in the beginning, like that. Then
And you just compose.
I can't see the result of the type of FODEM, dude. This is it was much better with the old one, but I guess now I can. No, I can't.
Yeah. Can you hover with your mouse?
I am hovering.
Click on somewhere else first. Now try. Yeah, it doesn't show.
But it showed for a split of a second there. You saw that?
No.
Okay, so pay attention. Look at the bottom there.
Yeah. Oh, isn't it the same? Yeah, I think it is the same thing as it's showing now.
Okay, so
You're
worse
hallucinating.
LSP. Great. So let me think about that. So what is the type of the function this? It is a result of these two things. So what we want to do, we want to pick this fold, and I think we can make it better. I do believe we can make it better. Because we can fmap it, because this returns a result, which is the return of the function. Best name, all of that. Then what we can do, we can pick.
Second, isn't it?
It picks the
Like the
second,
beef
but
filter.
the problem is that, dude, the problem. Okay, I
Isn't it
don't
a
know how
beef
to do
filter?
that. It is this.
What? Oh, okay. If that
Check
was another operator, it would be what the
satisfaction
heck?
list. Is that it? That's my
I don't
question.
know. I don't think so. You still need the second, right?
You are right. I still need the second. So let's work on that. Okay. Okay. So if you return a right, that means that it is an infinite primitive. Then you're gonna do the fold using the function. You're gonna do whatever you need. And then after the end, you're gonna have a satisfaction thing, and you're gonna check that out. Yeah. Yeah.
Just run this, man. I am curious. I want to see if it's
Just
working.
run this. Okay, so let's see first if this is compiling. Ah, it is.
Hey, I'm impressed.
So now let's go to main and let's make an example, right? Because now we have integers and strings and rationals, apparently. So
Yeah, I
let's
hope
be
so.
a little bit more ambitious. Let's put an integer here. let's. I want to remove the wildcard for now.
Yeah, put a p literal. Oh,
Uh, well, let's do the following. Let's comment this line and let's make
p
some things
literal
here. So p literal, we're gonna pattern match with an L integer, and let's put the number 1. Let's not put a guard, and let's put I don't know, whatever.
unit.
Yeah, e literal L unit. Yeah. So let's make another one in which is also going to be a number. So this should be non-exhaustive.
Mhm.
That nothing e literal e unit. That should be it,
L
right?
unit. L unit.
L unit.
L
Oops.
unit. All right. Yeah. Let's see.
Okay, so we have a problem. Oh no, this needs to be another number. Wait,
Yeah.
are we checking for that?
I don't know.
Uh,
I don't think it should do is on the on the type anyway. Type checking.
oh yeah, no, wait.
It's just to see which one you're talking about, right? To see which branch it is.
Wait. Oh no, you're right. Checking which number it is, that's runtime stuff.
If it doesn't work, I have a proposal of just disabling the type check locally, you know? So when you pattern match, it doesn't
Oh.
type check. Couldn't satisfy exhaustiveness. Exhaustiveness is wrong, isn't it? There's
I
an
have no
H there.
idea.
After the X, there's a H, I guess.
Are you
But what
sure?
was there? I didn't read.
No, the
Yeah,
error is
exhaust.
correct. The error is correct. Couldn't satisfy exhaustiveness with that. So
Yeah, but
now,
that's not an error, right? That's a warning.
that's an error. That's an error.
Why?
Because you need to have a catch-all when you have infinite
Oh,
sets.
see, you got a different number. Yes,
Yeah.
put true there.
Uh, oh, you mean true the number it's that we are.
Yeah,
No, but that
then
will
it
not
shouldn't
match.
be
That
an
will
error.
not match. We're still gonna have an error. That's runtime stuff. Discovering which number you are pattern matching. That's not
Yes, I
type
know,
checking.
but why is it a type error then? It shouldn't be.
Well, it is at the moment. It is.
Yeah, okay, but this should be a warning, not an error. Well, Okamo handles it as error by default, but
Okay, so let's do the wild card now. So this is the what we need want actually. So E literal L unit.
okay.
So this should be a
Check.
catch-all. Yes, it indeed worked. Okay, let's try another catch-all, which is the p variable. Now let's give it a name. Let's say that we have nothing. Let's say that we have L unit as well. This should also be a catch-all, and it is. I'm impressed. Theoretically speaking, we did 3 in one single shot.
Okay, commit this, man.
I need to change the name of this function though.
Why not? Function, it's perfect.
No, 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 no. Uh, fold infinite primitives. Yes. Yeah, this worked. I can't portray how happy I am that this worked. So we did 3 today. Strings, integers, rationals. That seems alright, right?
Yeah,
Hello?
I guess. Yeah.
Yeah, I guess. Yeah, I guess. That's what Magita is saying. That's very interesting. That's very interesting.
Ah, dude.
Ooh, wait.
What?
There is a test that we should do. There is a test that we should do. We should change this guy to an L string. Put whatever in here and see what happens.
It should be a type error, I guess. This should
That's
be a
the problem.
this should be a type error.
Yeah, so I guess there is an oversight. No, we overlooked
So
a limitation.
the types that we wanted there were to ensure that it would always be the same,
Oh, I
right?
see, dude.
Yeah.
Not when you do and we call it an literal, we don't actually
It can
care which
be
literal it is
yeah.
anymore.
Yes, and you just see the kind of the literal that we're passing to see
No,
if
the
all
kind
the
will be the same,
branches.
right? The kind of the strings, the rationals and the integers in
No,
this case
no.
are they are the same, all the
Yes,
same.
but what I'm saying is, if you send two of them, like integers and strings, they're both literals. But
Yeah.
we need to should lock the fact that it in okay in this thing it's locked by the attribute on the match on the to match. Just a sec.
Yeah, so there we overlooked something. So when you abstract things out, in this case you are losing detail that you care.
Yeah,
We
I
are
didn't think
losing.
of this by the way.
No, but that's the thing. That's why it felt it so wrong when I was doing it. Because I said, man, why we were talking about A's and list of A's if you can just use the literal itself? And something is, I'm missing something. There's something here. And that is the something. When you abstract the thing out as a
We have
literal,
the type right, so we can do a tuple there.
you can do a tuple.
Yeah, like you have the type before, so you can send it as a tuple,
Oh,
literal, and then the
that's
type.
not a bad idea. So you receive the type as well.
Yeah, and then all of them need to be that type, and then if it's not,
Ah, that's very interesting.
I would do a
So,
tuple. I think it's easier, but
dude, wait.
I need to adjust the
Then
interface.
I
I don't
have
know
to call
where
type
things come from.
checking. What the fuck? Did you see? Did you see this? What I said?
Oh, you on the literals? You mean?
No. I mean, yeah, on the literal itself, because we cannot pattern match and get the result out of that. We're gonna have to call type checking. Like, we're gonna have to do something like this, like
Mm.
literal type, and do like type checking expression,
Do
and
you need
yeah,
to do
we
this?
yeah we do because the only way to discover that the type of this literal is different than this type is to type check the literal.
Wait, but this literal. No, wait.
Am I missing something? Nathan is saying pattern, whatever with type, not type checking. I have no idea what you're talking about.
Nathan always types in a way that I don't understand anything, man. It's always elusive.
Relation. Okay, so there is a
Really.
relation between a pattern and a type, not type checking. I have no idea how you're gonna do this then. Because we only know there is a literal. We don't know which literal it is, right?
Yeah, we would need the type for the literal.
Yeah, and we can, right? We can just call like e literal x and some sort of environment for that. In this case, even the prelude would be enough. And then you get that type and then you compare them.
But I
And
think
if
you can do this before if it's going to be there. Because what's the problem? The problem is just that all the other branches they cannot be of distinct types, right? They need to have the same type. So
Wait, Nathan asked something important. You want
you
to
want
know
to
if a
know,
given pattern is valid for the type? No.
yeah, well, it is kind of right. It is like we have the thing to match, and we
No,
want
the
to see if
pattern is
all of them
valid.
need
The
to be
pattern
all.
is always, it is
No, it
p
is
literal.
not.
No, it is. P literal is valid. The
No,
problem
okay,
is that
but
we
in this,
care about which literal is being carried.
yeah, okay, I see what you mean.
So the problem is that, oh, p literal is fine, but I do care of which literal is there. Then, in my mind at least, the only way to know that without doing pattern matching, right? That's something important, Nathan. We can't do pattern matching. That was the whole problem before.
Dude, that's the information that you lost. Since you are not doing pattern matching to discard the wrong patterns for a given type, you lost that.
I agree.
Then the answer to the question is do a function that says if you have a given pattern is valid for a given type. That's it. You don't need type checking.
Do a function that for a given type and a given pattern show that if it's valid or not.
But they still have the problem of you being able to do different patterns that are, well, for example, you cannot do pattern. No, I think it
Since you
solves the question.
receive the
So
type, you can check all the
yeah,
patterns
check all the
against it,
type.
right?
Yeah,
Yeah,
and
I
always
think
need to
I see
match.
what you guys mean. I think I
Yeah,
see.
need to always do this in matter of the V you're matching. I'm thinking of the match clause. Yeah, makes sense.
Okay, but let's do this not now. I'm gonna commit this. I'm gonna finish the stream as well.
What to do, man? I think we're gonna forget this.
Okay, I will add a to do. So, to do. We need to identify if a certain literal can accept a certain pattern. Actually, it's not this. It's a certain type. Uh, in order to not allow mixing different types of literals. Okay, I'm gonna finish the stream.